Welcome to part 3, the last of the 3 parts of the one-sided limit videos. Here we have everybody's favorite piecewise functions. You're going to see that these are pretty easy, especially when it comes to one-sided limits. The first one says it's a one-sided limit as x approaches 1 from the left of this piecewise function. So all you need to do, you're going to do this numerically, basically. All you're going to do is figure out, well, which side am I using? So it says you're approaching 1 from the left, and this limit is pieced this way. This piece when x is less than or equal to 1. This piece when x is greater than or equal to 1. Since you're approaching 1 from the left, you're only dealing with this piece. So you can do this numerically and use, say, 1 or 0.999, but you don't need to because you know this function is continuous up through 1. It's a line. So you can just evaluate this function at 1, but make sure you're using this piece. Even if the equals is there, it doesn't matter. If it looked like this, you'd still use this piece because remember, the limit never gets to 1. So you're definitely always to the left of 1 here. So you have to use this piece that's to the left of 1. So when you plug in 1, you get 2 minus 6. 2 minus 6, which is negative 4. So the next one should be very easy if you understood that. It asks you for the limit as x approaches 1 from the right. The part of the limit that exists to the right of 1, according to this, is this. And just like I said before, it doesn't matter what this function equals at 1 because the limit never gets there. Therefore, the answer to this question is still f of 1. Well, actually not f of 1. F of 1 would be here. So let me get rid of that. That would be confusing. It would be whatever this function is at 1.00001, which would be plugged into this function. So you could plug in 1.001 into this x squared, but since it's continuous, you can use 1 safely. But make sure you use the piece where 1.001 exists. So that's 1 squared minus 3, which is negative 2. And that also tells you a lot about the graph. So that was short and sweet. So we have time to check. So the graphing calculator does not do a good job with piecewise functions, as I've said before. I'm going to use Desmos to check. And I would encourage you to go use Desmos and check all these things and explore it a little bit because it really helps to make sense of all this. So here's what I did on Desmos. To graph this piecewise function, you would type in 2x minus 6, and then you have to use these squiggly brackets here, and that would give you your domain. I put x is less than or equal to 1. To get that, all you do is type x, the less than sign, and then hit equals right after you hit the less than sign, and it will change to less than or equals. So that's pretty easy. And it shows you that piece is the red graph, this piece is the blue graph. So that's what the graph actually looks like. Remember, the first question said, what's the limit of this function as x approaches 1 from the left? So I'm looking back here. You said it should be negative 4. I'm looking back up here. So when you look at this graph, and I approach negative 1 from the left, down here, approaching -1, approaching -1, approaching -1, stop. You can clearly see that I am at -4, and therefore our answer was correct. In the same way, the second problem asked us to approach 1 from the right. So here we go. Approaching from the right, approaching from the right, right, stop, right here. You can clearly see that that limit is -2, which is thankfully what we got. Done. That's it. So that's all I want you to focus on now. I'll probably give you some problems to do because you probably have time. Go back and rewatch any of these videos if you need to. When you get back to the live session, we'll talk about graphs, and those are going to be very easy because you've basically done them before. So I will see you soon.